All right, so we should start with our agenda, right? Make sure we know what we're doing today. So if you remember yesterday, we kind of revisited dilations and similar figures. And so we thought about the side lengths are in a ratio to each other. The angles are congruent. The sides are, the line segments are parallel. We're going to continue on that today. We're going to first start with talking about how we can calculate using the ratios, so we can look for unknown side lengths. Just gives us a little bit of a warm-up into how to use ratios to help us find unknown measures. And then we'll jump into similar triangles in particular, and what we looked at with the special right triangles, see if that kind of pattern that we were seeing applies to more than just the special right triangles. So is there a way to calculate those side measures without using Pythagorean theorem? So we'll talk about this investigation when we get there. That's why you need the ruler and the calculator. This is going to take us today, possibly tomorrow to do, and then we'll talk about it as a class whenever we finish up as a group. So I'm just going to take a minute to pass out this first it's kind of like a warm-up. If you can just read the top part, you don't need to start doing it, but if you can just read the top part and try and make sense of it, and then once everyone has one, then I'll lead you through at least the first part. There you go. You're welcome. There's only 3 of you. There you go. Ladies, I don't think you were here when I said you should get out your field guide from yesterday and that dilation example. Just might help you. Yeah, you can borrow a compass up front. It's on the front white table there. Okay. Yeah, those 2. Does everyone have a copy? Okay, let's take a look at this together for a moment. So if you wouldn't mind, I'd like a couple of volunteers to just tell me what do you notice about the picture and about the measures. And there's some words up there. You can even read what it says. Go for it, Kate.
That the image is a dilation.
Dilation. Speak a little louder. So you think it's a scale factor between 1 and 2? Is that what I heard you say? Okay. So which one was the original? Which one's the image? Just to make sure we're clear. Okay, the solid lines, and the image is the one with the dotted lines, right? And we also know from the little primes on there too. Okay, so you thought that the scale factor is going to be more than 1. So how do you know it's more than 1?
Because where the points are placed, I remember it was basically you look at where the prime of the point is, and then you see how far how big the change is.
It's farther away from the point of dilation, right? So it looks like the point of dilation is here. Okay, awesome. Okay, so so Kate already did part of the work for us in figuring out that the scale factor is going to be bigger than 1 because it's moving away from that point of dilation. So let's actually calculate that scale factor. And we're going to do 1 and 2a together. And then I'm going to have you do 2b and 2c in your groups. And then we'll talk about how you did those too. All right, so it says, what's the scale factor? And we're going to use side AB and its image. So notice we were given those 2 side lengths already. So one of them is 2 centimeters and the other one is 3 centimeters. So when I do a scale factor, somebody want to help me out with what do I do with those 2 numbers or those 2 side lengths? How do I figure out that scale factor? Want to try it,
Ashley? Because your original scale, like your original image, the side side length on that is 2 centimeters, so to see how much it dilated, we'd probably subtract that from your dilation side length. So you'd subtract the 2 centimeters from the 3 centimeters.
So I would get 1.
Yeah, and then you would add that to your original length. Well, you'd see, like, because you have...
You're trying to figure out the extra distance it went, right? Compared to the original distance?
So that's 1 centimeter, then you'd add that to the, you'd see that that's half of the original. So that only dilated about a scale factor of 1.5.
Okay, so you're saying this went up 2, right? That's a length of 2, and this is 1 more than that. So you're saying the scale factor is going to be
1.5.
1.5. Okay. Is there a way that I can use the 2 and the 3 to get to 1.5? Does anyone want to help Ashley if maybe she's not seeing it right away? Maybe she is seeing it. Are you seeing it, Ashley, or not? You want some help? All right. Daniel, why don't you try?
You can just divide the second image by the first image and get 1.5.
So 3 over 2? So Ashley, what do you think? Would that work? Would that give me 1.5?
Yeah.
3 divided by 2? All right, so I think it's been a long time since we've done this stuff, so totally understand that you wouldn't know it off the top of your head. But I liked the way that you both rationalized through, like, okay, I know it's bigger than 1. It doesn't look like it's 2. How can I get to that? Your method, Ashley, I think works really well if we're using nice integer numbers. But I don't know if you noticed, but our other numbers are looking not quite so nice. So we'll try and come up with this, this fraction or ratio like Daniel was suggesting. And that's what we ended up, that's kind of the method that we agreed to use during first semester. So I'm going to put the image over the original. And then I can put those 2 numbers in. So 3 centimeters divided by 2 centimeters. So you can look at it as 3 over 2 or 1.5. Both of those are our scale factor. So now that we know that scale factor, we can use it for any other set of side lengths to figure out one or the other side length, because we know that it's always going to be in that scale factor of 1.5 or 3 to 2. And I want you to think about both the fraction and the decimal versions, because sometimes it's going to be more convenient to use the decimal. Sometimes it's more convenient to use the ratio or the fraction. Okay, so it says using the scale factor that we just found and the given lengths, so we were given some more lengths up here, we're going to find B prime, C prime. Okay, so is that an original side or an image side? It's an image, right? Because it has the little primes there. So if I go with the same order of the fraction that I used in the in number 1, I would put B prime, C prime on top, and then its original on the bottom, which is BC. And then I'm going to say equals, and we can either use 3 over 2 or 1.5. Which would you rather use? Doesn't matter. 3 over 2? Okay. Kate spoke up first, so we'll use 3 over 2. So now I know side BC, right? They told me that up top, 2.83 centimeters. So I'm going to substitute in for BC 2.83. So same proportion. Because I have 2 ratios that should be the same, so I'm just trying to figure out what B prime C prime is to be able to show those 2 ratios are the same. So how can I get B prime C prime by itself? What should I do? Kate, go ahead.
Is it possible you could square root it?
I don't see a squared there.
Oh, yeah.
I'm trying to undo dividing, right?
You want to multiply it?
Uh-huh. So I multiply both sides by 2.83.
Okay.
And by doing that, I will be able to simplify that to 1, so cross it out. So I get B prime C prime equals, and then you all have calculators out, so if you wouldn't mind calculating. Grab your calculator. Somebody tell me what number you get. 4.245. Maybe we'll round it to 4.25. Is that okay? So side BC equals 4.25 centimeters. And Hannah, just one more question for you. Does it seem like it would be 4.25 centimeters? We said that that B prime C prime said that B prime C prime is, oh, we're looking for B prime C prime, sorry. BC is 2.83 and B prime C prime 4.25. So this one's 2.83, this one's 4.25. Does that seem like that makes sense? And how do you know that? You don't have to think like mathematical. What do you know about the original versus the image? Which one's bigger, which one's smaller?
The image is bigger than
The original.
by like 1.
So 4.25 is bigger than 2.83. It's more than 1 time. It's not as much as 2, right? Because that would be like, I don't know, 5 point something, right? Okay, good. I wasn't looking for like lots of concepts. Just makes sense because it's supposed to be bigger. It's supposed to be longer. Okay, so there's one example of how we might find an unknown side length. So all I've done is put the same ratios of side lengths equal to each other and solved for what I don't know. So if you can try and find C prime D prime, the length of that, and the length of DA, you can work in your groups and you can talk to each other about it. I'll kind of walk around while you are trying to work on it, and then we'll talk about it as a class once everyone's had a chance to do it. Questions about what you need to do? All right. Instead of?
Why right here? Should I simplify over its size?
That's another version of 1.5, the scale factor. So, but you can use either one, right? Because they're equal to each other. They're just 2 different formats. Yeah. 3/2 is the same as 1.5. Use whichever one seems to make the most sense to you. Yes, ma'am.
Rewrite it C prime D prime to the.
It was on that side. We were trying to
So if I look at one over the other, this is just a ratio of their side lengths. So my scale factor is 1.5, which is the same as 3/2. It just so happened that those side lengths were actually 3 and 2.
Oh, wait, so if I was figuring out for C prime, D prime, I would use these ones?
Well, you need, if you're using C prime, D prime, you need CD, right, which you have. And then you already know the scale factor. So this is just another version of the scale factor. This will equal 1.5 when you're done. So you're just trying to figure out what's that number to make this 1.5.
Oh, so what do I write here? It would be,
You could write 1.5 if you wanted to, or you could write 3/2.
because that's the,
You're doing image over original equals image over original. Does that make sense?
okay, so it would just all together equal 1.5.
Right. This is just another form of 3/2.
Oh, okay.
Is it kind of,
Yeah.
because we haven't done a lot with ratios in this class. You did a ton in 7th grade, but that was 3 years ago. So I wanted to give you guys some practice before we jump in and start using them a lot.
That means we would do
No problem.
B A over D prime A prime.
Yes, ma'am.
Or would you just keep it the same?
Have you guys talked to, or have you guys tried that one yet? Not yet.
Which one? C.
You're working on C right
Is it
now.
meant to be primes there?
So what are you thinking, Molly?
Yeah, this one has primes.
Well, you guys talk to each other about this. I won't go anywhere, but
Well, it just wouldn't be
And then these ones have
would you just keep it the same?
primes in these two.
Like,
Okay.
Do you just keep DA at the bottom, just normal like you're doing with CD, and then just keep it the same up here because that's what you're trying to figure out?
So when we talked about the scale factor being 1.5, we were saying it's the scale factor because we did image over original. But if we wanted to compare original to image, we would just do 2 over 3.
Because it's not prime.
If you want. It's, what's important though is that you're comparing ratios that make sense, like you're doing original over image equals original over image, because you have to, you know what I mean? If you flip it upside down, they're not equal anymore. Does that make sense? So you either flip both or don't flip either.
DA over D prime A prime.
Oh, but it's not because it's not.
Oh, but there's not, the A is not a prime.
3 over 2.
I feel like
So this is the decimal version, this is the fraction version. They're both the same. So if you wanted to use 3 over 2 here, you could, or you could use 1.5. Doesn't really matter. Either one's the same. So this is image over original equals image over original. So those should be equivalent fractions, so that makes sense. 2.9. Oh.
Why would we divide it by 1.5 then?
Sorry to hear that. So these old ones then?
You guys said so.
Gotcha.
I got the answer, but I just
So,
I
okay.
divided.
But you do have CD though. You're trying to find C prime, D prime?
Oh, so it's me a time if I.
Well, you're gonna substitute that number in. So C prime, D prime over that number,
DA over
and then equals.
over DA.
And you can write 3/2 or 1.5.
DA over D prime A. Well, we have to write it like that.
No, this way.
Why don't we just divide it?
So try and type into your calculator. We did 3 divided by 2 times 2.83
D prime A over D.
times.
Yeah, but we put the.
Does that make sense? So, and on this side, we can cross those out because they simplify to 1, because you have a 2.83 on the top and the bottom.
So I get it. So we would, no, we would do DA over.
Well, you're trying to get C prime, D prime by itself, so how do you get rid of the divide by 3 point? Right, multiply both sides.
There you go.
But it would still be 3 over 2, right?
If you do it to one side, exactly.
So then would I multiply that times that?
3.16 times either 3/2 or 1.5. Either one is the same thing.
How do you do without the prime?
Where did you get?
It's just like the same.
Well, you guys, I want you to talk about that one. I will try and answer another question. Try and think through it and see if you can get a way that will work for you.
Okay.
Yes,
we're
ma'am.
confused on if D prime A goes on the top or if D A goes on the top.
Does it matter?
Not really.
So if you think about what we talked about with the scale factor, we wanted one on top and one on the bottom, so we knew that our scale factor made sense when we were talking about original versus image. But if we just need to find a side measure, we know that this ratio is going to be the same as this ratio. But a ratio always has to go 1 over the other. You always have to compare it the same way for them to be equal.
Okay.
Because we could have said 1.5, or if we reversed it, it could be 2 over 3.
Yeah, because.
Oh, okay.
It's still the same ratio, just represented one way or the other.
Okay.
But what's important is that you're always comparing little to big, or big to little, big to little. Am I making sense? And I guess I shouldn't use big and little, original to image or image to original.
Yeah, okay.
And so figure out what's easier for you, if you can, to solve.
Okay.
Good?
Thank you.
No problem.
3 over 2, you do 2 over 3, so you like flip the whole equation.
How are we doing here?
Do the same thing over here.
Do they all make sense? Think so? Is that one?
Yeah, but you have to write 4.7 on the bottom.
Okay. You too? Same stuff?
If you, if, I
Did
know,
you guys compare answers? You should compare answers, right? That's why you're sitting together?
And then
especially talk to each other about C. Call me back over if you need to. What do we think?
I think we got it.
You compared answers?
Yep.
Then D prime A would go on the top. You just said that didn't matter.
So tell me what you did here.
Well, I decided to take it out of the fraction form and put it in
Decimal form? Okay.
and I switched the, like, I put like the measurement of D prime A and put it below, or I mean above, and then I divided by the scale factor.
Yeah, airborne.
So I think I understand what you're saying. You did original over image here, but you kept
Oh, I
this as
switched
image
it.
over original. So maybe you should fix like this over here.
I changed it to like,
Does that make sense?
yeah.
It'd be 2 over 3, right?
Actually, I have a little line on my arm.
Why would it be 2 over 3?
Well, he did DA on top, which is the original.
Yeah.
So when we're comparing, like doing a ratio, if I say girls to boys in this room and then go to the next room and say boys to girls, the ratios aren't going to be comparable, right? I have to do original to image both times or image to original both times. So he had before original over image equals image over original. And that doesn't make sense because it's not going to be the same ratio if you flip it upside down, like the fractions mean something different. Does that make sense?
Yeah.
So you want your work, you ended up getting the right answer, but your work is a little confusing looking, right?
Not organized.
Well, and it's not that you don't understand the concept, you just need to know how to show it. So what you might do is take this and recopy it, put the length in that you know, right?
Yep.
And then see if you can show the algebraic steps to solve so that you end up with that answer.
All right.
Because we'll get some situations where we won't have a nice picture to look at, and we got to make sure that our ratios are in the right spots. Okay, raise your hand if you could use some more time. Okay, I'll give you another minute or so, and then we'll talk about these two. Yes, ma'am.
So I don't get how I'd find this because I know I have D prime A. Am I doing it right?
I don't know, are you? So, Angel, explain what you did, and we can kind of talk through it all together. And Letty, you listen too, so that... No, but listen, so we can figure out together.
I want to take pictures of
So you put DA on the top because then you don't have to rearrange it to get it on the top. Okay, so she did DA over D prime A. So you did the same thing, looks like. Were you thinking the same thing, or you just decided you wanted to flip it?
Yeah. I go hang out with him.
But now you're saying original over image equals this ratio represented image over original. Do you know what I mean? Like so we said image over original is 3 over 2, which is 1.5 up here, right? So 3 over 2, but that was image over original. You've done original over image and said it equals 1.5, where really we need to flip-flop those two numbers and it becomes 2 over 3.
I don't want to get there right at 7. I don't get there at 7:30.
So original over image, this is image over original. You have to have them the same way. Does that make sense?
Yeah, homecoming. Remember homecoming? We were literally like the first people on the floor. We were
Well, it wouldn't be this decimal anymore because it's 2 over 3. Right. And Letty, the reason I wanted you to talk to us is because you said that DA, which is shorter, was going to be longer than this one's what, 4.74, and you said that one's 7. But it's only because you had that ratio upside down. Does that make sense? Okay. I'm sorry.
I'm really surprised the teacher did not.
I don't think so.
I don't think they would want to go down there.
2 divided by 3. Oh, you rounded a lot by doing 0.6. Do 2 divided by 3 times 4.74 altogether. Yep, 2 divided by 3
there, and you give directions.
Times.
Literally 2 years ago. It was like
You give directions.
4.74.
Yeah.
Yeah, 3.16. Would the two of you be willing to talk us through what you were thinking with C? I think it's really important what we just talked about. Would you be willing? Okay. If you guys want to join in, you can.
No. So like,
No, you're just going to tell me what to write.
something like called my name. I'm like, oh, what's this sound?
I see.
Like, there were no
So you did
There were lights, and then I walked
CD
in
over.
I'm like fighting my brother. Am I in the right house?
That's right. Okay.
Did we do it right?
So ladies, could I don't care who does it, maybe since Ashley's already talked, one of the three of you, or more than one, talk us through B. I'm going to just do it on the board however you tell me to.
No thanks. You can take them.
Why don't one of you tell me what to write, and the other one explain why you wrote it that way?
Well, what would I say? Like,
Tell me what to write.
Do I just say like what the measurements are? Like I can write it down. I was gonna make a mathematical
Should we make the congruent?
What's that?
That's what I did. Because these,
C and D and G.
They are congruent. That was not on purpose. But I'm glad you noticed. I don't care. Whoever wants to talk with the group. Okay, if you could wrap up your conversations, please. So let's talk through what we did on B and C. I twisted a couple of arms, and we have some people who are willing to talk about what they did in B and C. If the rest of you could look at the method that they used and think to yourself if that method makes the most sense to you, if your method makes the most sense to you. I want you to think about also, in 7th grade, you may have learned how to calculate with scale factors similar triangles. You spent a lot of time actually in 7th grade on this. But I want you to think about how to represent things algebraically for when the problems get more complicated. Again, because remember, we're 3 years older in our mathematical thinking, and so we want to use methods that will carry us forward instead of the methods that might have worked well back when we were, what age? 12? Does that sound right? About 12? Right. So you've matured a lot since then, and your brain knows a lot more about how to represent things mathematically. So try and figure out how to document what you are figuring out, not just calculate it. Okay. Go for it, ladies. Part B.
So for B, we're trying to find the length of C prime D prime. So we wrote C prime D prime over CD equals 3 over 2 because that's your scale factor given for image over original.
Right, so you were doing image over original equals image over original.
Yes.
Okay?
So then we wrote C prime D prime over 3.16 because it gives us the length of CD
It's 3.16, okay?
equals 3 over 2.
Okay.
And then to get C prime D prime by itself, we multiplied each side by 3.16.
If we do it to one side, we got to do it to the other. If you need to, remember that that's over 1, okay?
Which you can cross those out. So then that gives you C prime D prime. And then 3 over 2 times 3.16 gives us C prime D prime equals 4.74 centimeters.
And so how did you know that that number made sense? So you had CD was 3.16, and you're saying C prime D prime is 4.74.
Yeah, so that's not exactly 2, but it's over 1.
Yep, so C prime D prime is bigger or longer than CD, and we're supposed to head in that direction, bigger or longer. Okay. Other ways that you did part B? How many of you set up a proportion kind of the same way? How many of you used 1.5 instead of 3/2? That's also appropriate to do, right? So you could have done C prime D prime over CD equals 1.5. Multiplied both sides by 3.16. You would have gotten the same answer. All right, awesome. All right, back table.
Okay, so we had to find the length of BA.
Uh-huh.
And what I put BA over D prime A. And the length I got from that is 1 over 1.5.
So you said, I'm going to do original over image this time instead of image over original. And so you took your original scale factor and also flipped that over and made the reciprocal. 1 over 1.5. Did I get that right? Mm-hmm. Sorry, not high enough up. Okay. All right, excellent. What's next?
After you've gotten 1 over 1.5, you will take DA and put it over 4.74.
Because you knew that number, right?
Yep. Equals, I said 2/3.
So you had, instead of 1 over 1.5, you took 3 over 2 and turned it upside down. Same number, right? Okay.
And then you multiply both sides by 4.74.
All right, so times 4.74 on both sides.
And you end up with DA equals 3.16 centimeters.
3.16 centimeters. So our original number was D prime A. So this number here, we said was 4.74. And so does it make sense that that side length would be 3.16? And why does it make sense?
Because it's smaller than the
You got it. Because we're starting with image and going backward to original. And original is smaller. So if you've noticed, we've used these ratios in several different ways. We've used it as a reciprocal. We've used it as a decimal, as a fraction. All of those options work. What's important for you to think about is if you're comparing two ratios, you have to have them organized the same way. So in this case, if you're doing image over original, then image over original on the other side of the equation. If you're going to flip it over, flip the whole thing over. Okay, and you might want to flip it over. We had a conversation in the back about, you want to make sure that DA is on the top, because if it's not on the top, you got to get it on the top, and then algebraically, that's no fun to do. So if you can get the unknown thing on the top right away, you have less things that you have to write down. Questions on what we've done so far? Okay, let's start on the main investigation. So I'm going to give you a packet. Each of you at your table is going to be a different set of points. Okay, so over on the side next to this graph, there are 4 groups. If you have 4 people at your table, each of you choose a group. If you have 3 people at your table, ignore group 4. Okay, so just do groups 1, 2, and 3. I do have some things to say about this once everyone gets it, but if you can at least pick out which number you're going to be, which group, and then once everyone's gotten one, we can look at it together for a minute. Here you go, ladies. Yeah, this is. Could ask for them back.
Can't give them back.
You should give them back at some point.
You will eventually.
Okay, if you could wrap up your conversations again, please. Okay, so all of you have an investigation now. Just take a quick look at number 1. In summary, number 1 says you're going to take those 2 points. One is on the x-axis, one's on the y-axis, and graph them. And then you're going to draw a line between them, and then, or a line segment, and then you're going to choose the origin as your third point to make a triangle. Okay, so this will be a right triangle because your 2 axes are 2 sides, so you have a right triangle. Then you're going to start trying to answer some questions from there. It is very important that you be very accurate with your graphing and your measuring, because we're going to do some measuring here in a minute too. Because if your numbers are off, it will mess up you trying to find the patterns that we're looking for. Because remember, we're trying to find patterns in these triangles like what we did with the special right triangles. Okay, so notice it talks about how do we know that lines are parallel. In number 2, number 3, it says to draw lines that are parallel. When you work through this investigation, each of you has a different set of points, but you all should talk to each other about, well, what does this mean and how do I find this? Very few of the questions ask you something that's particular to your points when they're asking you to explain. Okay, if you can look at page 2 for me for a moment. Top of page 2, notice that there's a table that you need to fill in. The instructions give you more detail, but you're measuring in centimeters, please. And please notice how I'd like you to fill in that table. So notice that top cell there says AB equals. So you're going to do the same thing each time. Write down what's the segment that you're measuring, and then you're measuring to the nearest 1/10 of a centimeter. So 1/10 of a centimeter means the small tick marks on your ruler. If you're not sure, ask the people at your table, ask me. Then you are in the last 3 columns calculating some ratios. So just like we did with the scale factor, you're going to write which 2 segments you're putting in your ratio, just like I've done in the first line, and then what are those 2 numbers that you're using as your fraction, and then it equals, write the decimal equivalent. So, and it says to the nearest 1,000th, which is 3 decimal places. Okay, once you're done with that part, and I don't know that we'll get to this today, so we'll probably do it tomorrow, but you have a marker, and you're going to write those 3 columns of numbers, so those 9 numbers, on your poster. There's 4 posters around the room, 1 for each group. You're going to write those numbers on that poster. My guess is we'll get to that part tomorrow, but just so you know, you're going to be writing those numbers on a poster as well. Then too, you have some other questions to answer. One of the only ones where you're going to have to use your numbers is number 7. So that's where, you can talk about the concept, how do you do the problems together, but you won't be able to compare answers. Most of you have gotten started. Is there anything that you have a question on before you start? Okay, so we'll work. We have about 10 minutes left in class, so we'll work and then we'll continue this tomorrow. I'll let you know when we can wrap up.
So we're just making our own triangle.
Well, I gave you the 2 points, right? And then your third point, it says point A is the origin.
Hey, how do you find like
The origin is point 0, 0. Yeah. And then those 3 points make your right triangle. One second, Hannah.
third point?
It says that label the origin A. So where's the origin? Yep. So there's your third point.
Oh.
It says label the origin A. Good?
Yeah.
Okay. Yes, ma'am. Yes. 0, 0.
Label the origin.
You good?
Yeah.
Oh,
Yeah.
it's
Do
0.
we use markers for this one? Are you guys connecting the lines between the points?
That's not good. Did we each pick a group?
Yes, we all
We did. Nice. Yes, ma'am.
Wow, my triangle's fast. You're
They're all right.
And she wrote it upside down.
Mine's so
Um,
cute. It's like perfect size.
So I don't know. You guys, how do we know how to draw parallel lines? What makes lines parallel to each other?
mean, I gotta think we don't.
Have you done anything wrong?
Well, if we could pick our slope, yes, but I think our slope has already been picked for us. I just gave you the answer.
Depends, like if my, how we do on my test.
Did you guys hear what I just said? No. So notice you have a steep line. Letty, let's look at yours. Not as steep. So what do we call that steepness? The slope, yes. Of course you are. You don't think you are, but it's fine. It just stabbed me, no big deal. I'm so sorry. I'm kidding, it hit my shoe. Sorry. I didn't. So if you know the slope, parallel lines have what kind of slope compared to each other? Parallel lines have what kind of slope compared to each other? Same slope. You remember that from the take-home assessment, where we compared the slopes, and if they were the same, we knew the lines were parallel? Does that make sense? So you need, yeah, so you're on your way. You need to be able to find lines that have the same slope in different places.
Ashley, did you figure it out yet? She figured it out.
But when I was like, I think in second grade, and we used to have to take like triangles from the boxes aside to like get the square root unit area.
Yes, to find the area.
Doing it instead.
We will revisit that technique when we talk about area and surface area and volume. I like that you can recall these things.
Wait, did we get to make the shape?
I don't know. We'll have to see how much time we have. We'll see. Yes. What are we thinking?
Because it's a 10 by 10.
So by measuring the slope, and then, so how would you know how to create another line that's parallel? So lines that are parallel, how do their slopes compare? So when you go to draw that next line, wherever it is, because it tells you in number 3 to draw them, you want to make sure it has the same slope. Does that make sense? And however you figure out that it has the same slope is fine. Slope triangle, calculating, just as long as it is parallel. Sorry. What's that? Okay.
How would I exactly draw the parallel line? Would I just like draw it like up a square or what?
Well, so we said if the lines are parallel, they have the same slope,
Okay.
right?
Yeah.
So you need 2 more lines that have that slope. So how do you know what that slope is?
How do you know?
How do you know what your slope is?
By where the points are?
Rise over run, or slope triangle? Like you actually have to find the slope for your line.
Oh, you do?
Well, yeah, because otherwise you need to be able to verify that your other line has the same slope, right?
This sucks. I hate finding rise over run. I could never do it in the 8th grade.
You should try to stop disliking it because you're going to keep doing a lot of it. It's a pretty essential concept all the way through calculus.
I'm okay in calculus.
I didn't say you were, but
I'm taking algebra 2 for the next few years. I'm good.
Okay, well, for this year, next year, and the year after that, you're going to have to know slope. So you can do it. I know you can. I'm trying not to. Am I scaring you?
Could you like try